Good day everyone, we'll be looking at a consolidated jamb question. So in this question they ask us to look for the work done in the graphical representation. So this is the graphical representation. So we have the positive y-axis to be the force, the force, while we have the negative y-axis to also be the force. Then we have the x-axis, which is the independent variable, to be the displacement x in meter. You see brackets here means what? In showing you the units meter. But here you can see it in Newton. So this is the displacement and this is the force. So the area of this graph will tell us what the work done will be. So the area here is simply the work done at this point. Let's call this one A. So this area will tell us the work done at this triangle. Then on this side, let's call this one B. The area here will tell us the work done here. Then at this C, the area here will tell us the work done at C. So if they ask us the total work done in this graphical representation, we need to look for the work done at A, the work done at B, and the work done at C. Then we sum them together, we get our answer. And take note, when you are summing them, you should do a vector sum. Yeah, that's what we are going to do. Now we are going to look for the area at A. How do you get the area at A? Because this is not a triangle. So the area of the triangle A is equal to that work done work done at A. The area here is equal to work done at A. And now what is the area of this triangle here is what? Area of triangle, the formula is what? Half base times height. So for A, it is what? Half base times height. So now we say half. What is the base? From this point to this point is the base of this triangle here. From this point to this point, that's the base. So what is it now? 0 to 80, that would be 80. That will be multiplied by 80, then multiply by what is the height. So the height is from this point to where it ended. Look at it now. This is the height. You can trace it down to this point. It will be 100 Newton. 100 Newton. So we can solve from here now. We divide this, we get 40. 40 times this, we get 4,000. 4,000 joules. This is the work done at this first triangle. Now let's look at the work done at this other one. So at B, we say half base times height equal to, okay, we say half. What is the base? From this point to this point, that is from 80 mark to 120 mark. So what's now from 80 to 120 is how many? That's 120 minus 80, that's equals to 40. So we say 40 multiplied by what is the height? This is the height from here now down. This is the height. So you can trace it down to here, minus 40. Take note, you have to include your minus sign while you solve. So how do we go? But we divide this by this, we get 20. 20 times minus 40. 2 times is 80 minus 800 joules. That'll be for B. Then how about for C? C will be equals to half the base times height. So we say half. What is the base for C? This is C. What is the base? From here to here, this is 120 to 180, and that equals to 60. If you 160, that is 180 minus 120, that's 60, right? So we say 60 multiplied by what is the height? And the height, you can trace it down, down, down. You can see it lands on 60. We say 60. So let's divide and further and get our answer. Divide this, we will have 30. Then 3 times 6 is 18. 1, 2, 1, 2. So we have gotten this now. Now we are going to sum these values. 1, 2, 3. That is A, B, and C. Sum them up and we get our value. Take note of the sign in this minus 800. You need to take note of that sign, minus 800. So now let's solve that now. Where can I do that? So minus 1 minus 800, from this we are going to get 1000. 1000 plus this we are going to get 5000. So the answer will be 5000 joules. That will be the answer to the question.